Hello my dear students, welcome back again to another session of our board exam smart series. So this time I have brought you the chapter metals and non-metals. So let's look at some few previous year questions from the board examinations, starting with the one marker. So these are from 2023 and 2024 one marker MCQs questions. So the first question reads as a metal and a non-metal that exist in liquid state at room temperature or respectively. So I'm giving you a time. Take a pause the video and try to answer all these three questions in a quick shot. So 1, 2, 3. So let's go ahead with the answers and the solutions for this one. So understand the sequence. They are asking first a metal and then followed with a non-metal. So obviously, which is the only metal which is liquid at room temperature? It is mercury. That's correct. And what about the non-metal? Which is the non-metal which is in liquid state in room temperature? That is bromine. So which is the correct option? The correct option is C. So if you have got it correct, well and very good. So let's move to the second question. The second question, the oxide which can react with HCl as well as KOH, which is potassium hydroxide, to give corresponding salts and water. So what is that oxide which reacts both with acids and metal hydroxides? Basically the bases are called as amphoteric oxides. So we have only two metals which are amphoteric oxide, which can form amphoteric oxides. What are those? Yes, that's correct. Aluminium and zinc. So you just check for the options which is containing either aluminium or zinc. So you can see from those four options only we have aluminium oxide, which will be the answer for the second question. So the correct option is B, aluminium oxide. So let's move to the third question now. Consider the following cases. There are four reactions which are given. Out of these four reactions, they are asking in which cases do you think a new product will form? That is basically the reaction where the chemical reaction can happen. So you know, according to the reactivity series, we have to go which can displace which salt, okay, the metal from the which salt. So obviously if you see calcium and aluminium, do you think aluminium is more reactive compared to the calcium? No. So this option can be excluded. Now coming to the second option, copper sulfate plus calcium. Do you think calcium is more reactive than copper? Yeah, if you see the series, calcium is more reactive compared to the copper. So it can easily displace copper from the copper sulfate solution. Coming to the third option, which is iron sulfate and copper. This is the most performed activity in our classes also. And it is copper sulfate is reacted with iron nail. Do you remember? So iron nail is, iron can displace copper, but copper can it displace iron from the iron sulfate? No. So obviously C option can also be removed from our options. Now come to the last one. Zinc sulfate and magnesium. Which one is more reactive? Obviously magnesium. So magnesium, can it displace zinc? Yes, obviously. So which are the two reactions that can happen in our four equations that are given? One is B and the second one is the D. So which is the correct option? Option D. Right? So let's move to the second question now. So this question was asked as a 3-marker in 2024 CBSE board examination. It's a combination of 3 questions. So you have to write all in statements. This is basically a statement theory problem, theory question. So sodium metal is stored under kerosene oil. Why? Why do you think that? So if you know the answers, you can pause the video and start typing the answers in the comment box. So what is the reason sodium metal is stored under kerosene oil? Because sodium is very, very explosive in nature. So if it is exposed to air or moisture, it starts to react. And what is the type of reaction that will happen? It's a highly exothermic reaction. So if it is a highly exothermic reaction, it explodes. So that is why to conserve the metal and not having any explosions and all, to handle it safely, we have to keep it in kerosene oil. So I will show you the answer how it has to be written, but these are the generalized statements. So B, some metal oxides are soluble in water. Yes, some they don't. What are the aqueous solutions of these metal oxides called as? So you know, some metal oxides, when they react with water, they form what type of products they do form, compounds they form? They form calcium hydroxides or magnesium hydroxides. So what are these? These are basic solutions, and these basic solutions are called as those which are soluble in water are called as what? Yes, they are called as alkalis. So one example I'll be showing in the next slide. And the final question, at ordinary temperature, the surface of metals such as magnesium, aluminum, yes, zinc are covered with a thin layer. So what is that layer especially? What is that coating called as? What is it made up of basically? So these metals, when they are exposed to oxygen, they form Oxide layers. Yes, they form oxide layers. And what is the need of these oxide? How do they help? How do they help the metals? They try to save the metal from further oxidation. So the generalized statements I have given, the proper statemental words which you have to use in the examination are displayed over here. And as I said, one of the example for the alkali formation is Na2O, which is sodium oxide. When it reacts with water, it will form, what is this? Basic solution and alkali, sodium hydroxide. So you can take a snap of this, or you can come back again to our videos to view the answers. So shall we move to the third question now? Are you all ready to see the third question? So let's move to the third question. Pause the video to answer. So now let's go to the third question. This is one of the most important questions which can be expected in the board examinations also. That is the formation, basically the electronic configuration of the metallic ionic compounds. Okay, so in this question it is asking you to write the electronic configuration of sodium and oxygen, and they are asking even to form the ionic compound between these two elements, and they are asking to name the anion and the cation. So let's first write down the electronic configuration of sodium and oxygen. So sodium, the symbol is Na. So what is the electronic configuration? It is having 11 electrons in the overall shells. So it is basically 2, 8 and 1. So it can, and even oxygen, what is the electronic configuration? It is having 8 electrons. So the electronic configuration is 2, 6. So what can you identify from these two? In order to attain the stability, that is to gain the electronic configuration of an inert gas, sodium can lose one electron. It can lose one electron and gain a positive charge. Correct? It can gain a positive charge. While oxygen, in order to attain the stability, it can what? It can gain 2 electrons. 2 electrons it can gain and try to attain the negative charge. Right? So gaining of electrons is basically gaining negativity. So from this you can see sodium can give 1 electron. Oxygen has to gain 2 electrons, but how can a compound form between these two? That means if you see sodium, what is the charge? +1, right? What about oxygen? It is 2 minus basically. So in order to form a compound between these two, you know the crisscross method which you have learned already in your grade 9. So according to the crisscross method, the compound that should be formed between sodium and oxygen is Na2O. Correct? So Na2O is the ionic compound which is being formed. But what is the electronic configuration? How is the ionic bond formed? We will see now. So I need how many atoms of sodium? I need 2. How many oxygen atoms? 1. So let's write only the outermost electron will be displayed here on top of the sodium. Right? So how many sodiums do I need? I need 2. So I will draw the second sodium also. Now these two will react with how many oxygen atoms? Only 1 oxygen atom. And how many outermost electrons are there? There are only 6 here. So there are 2 vacant electrons which it can gain. So where does those 2 electrons come from? Those 2 electrons come from sodium. So please do remember, even in examination also, you are supposed to show this transfer of electrons. Okay, so basically ionic compounds are nothing but transfer of electrons from a positive charged ion to a negative charged ion. So what is the ultimate result? So ultimate result you have to write it as, so Na plus and oxygen and with the filled electrons, and what is the charge here? 2 minus, it has gained, and one more Na. This has a positive charge. Okay, so what is this? What is the compound that we have formed? Na2O. Remember, they are even asking what is the anion and the cation. So how do you remember that anion and cation? That means which is positive and which is negative. So cations, I usually tell that if a cat has a paw, so cations are positive charges. So cation is positive. So that means which is positive here, which is the positive ion from our reaction? It is nothing but Na plus. Correct, that's very good. Na plus. What is the anion? Anion is obviously the negative charged ion. So which is the negative charged ion in our case? It is oxygen. So the answer is O2 minus. So this completes our solution for this question. Are you all ready for the next question? So let's move to this next question, question number 4. So question number 4, this is very important. So you have to pause a little while here and then move to the solutions part. I will give a little bit of time for this one because this is an OR question. So there are 2 questions involved in this one. So take a little bit of time and I will come back again in 1 minute. Okay. So have you all done? Shall I discuss with the solution here? So let's move to the question. So first question, state giving reason for the reduction process to obtain the following metals from their compounds. So what is the concept in all this one? It is the, yes, correct, extraction of metals. So this and all involves the extraction of metals. So what type, I mean, like we have the categories in the reactivity series, right? One is at the top, one is in the middle, the other one is at the bottom of the reactivity series. Now where do you think mercury falls under? Where do you think copper and simultaneously sodium fall under? So we all know mercury falls under the lower end group, while copper, where does it fall? It falls under the middle group. Basically it shows both the nature of the middle as well as the lower end. And coming to sodium, it is at the top after the potassium. So what can be the answers for this? How can the reduction process help in gaining the metals for this one? So let's look at the answers for them. So coming to the first one, mercury. Mercury, how is the compound available in nature? Compound, what is the mercury compound available? It is HgS. What is the name? Mercuric sulfide, that is nothing but cinnabar. Yes, mercury is obtained from its compounds through the reduction process because it is less reactive than hydrogen. So it is below the reactivity series than hydrogen. Okay, so generally mercury, like I said, it is found in the form of cinnabar, which is HgS, mercuric sulfide. So when you heat it, okay, nothing else is required for mercuric sulfide, that is cinnabar. You have to just heat it. If you heat it, what is the first process that will happen? It will convert into HgO, which is mercuric oxide. After converting into mercuric oxide, how do you think it is reduced to the metal? Yes, tell me, come on, yes, you have to pass through reducing agents. Which is the most common reducing agent? Correct, carbon. Carbon is the most common reducing agent which is used. So further reduction of mercury with carbon or hydrogen also we can use to get the mercury, elemental mercury. So this completes your mercury reduction process. What about the next one? Copper. Like I said, copper can be even obtained through heating process or even through some of the middle reaction process like the calcination and all those things. Okay, so copper is obtained from its compounds through the reduction because it has a, again, lesser potential than hydrogen. So copper ores such as Cu2O and CuS, copper sulfides, are reduced through the elemental copper. So you can even use calcination and roasting, which can be which will be discussed in the next coming slides. So coming to the sodium, how do you think sodium can be reduced? Can it be reduced using oxygen? I mean, like, can it be reduced using carbon reducing agents? No. Why? Why can't we reduce metallic oxides like sodium oxides or potassium oxides with carbon and all, or hydrogen in this case? You know, hydrogen is below in the reactivity series of sodium and potassium, correct? Right. So they have more affinity. What do you mean by affinity? Affinity is nothing but the attraction. So these elements, like higher reactivity elements, they are more attractive towards oxygen compared to hydrogen and carbon. So because of that reason, we can't, just by heating, we can't reduce it into the metals. So what do we use? What is the method that we use to refine them? Yeah, I'm using the word. So are you able to get it? So it is called as electrolytic refining. So electrolytic reduction is used to bring the sodium ions. Okay, I mean, like sodium metal. So this completes our first question of the this choice question. What about the second question? State giving reason for the change in appearance. See, this is covering the reactivity series and how we are extracting the metals. Then what about this question? Which concept of metals and non-metals do you think this is covering? So basically we have chosen some questions covering all the points from the whole chapter, metals and non-metals. So this is covering which part? This is covering, yes, correct, that is covering the corrosion part, the tarnishing part. So let's move to the, this is basically, there are only 3 points. If you go through the textbook properly, there are only 3 elements which were given, and those 3 elements only they have given as a question also. So why do you think silver, copper and iron changes over an exposure of time to atmosphere? So what can be the reason? So we have listed down what is given exactly in the textbook, because if you follow NCERT and if you write down the exact statements, that it will that itself will fetch you the enough marks which is required. So let's move to the question answer. So yeah, silver. Silver, when basically all the articles, if you expose to air or atmosphere, even you can see I am wearing a silver ring here. So after few days, you can see some black coating over this silver ring and all. So I used to wonder what is the reason behind this one. So when I started to study during my age and all, I started to learn that there is sulfur present in our atmosphere, right? So minimum. It takes time. It takes time though. So what it forms is AgS, which is silver sulfide. It will form, and that silver sulfide compound, it's nothing but it's blackish in color. So that is the reason the tarnish happens with the silver metals. Now what about the copper? You know the Statue of Liberty, right? So when it started, it looked in a reddish brown color. Now suddenly it is looking like a greenish coat color. What is the reason behind this one? It is nothing but the copper carbonate which is being formed when it is getting exposed with moist carbon dioxide. Got it? That is nothing but patina we call. So please go through that concept again one more time. This is very, very important regarding the corrosion process. Coming to the last one, obviously no one should be able to, I mean like everyone should know it, that when iron is exposed to air, moisture, basically what do we get? What is it called as? Fe2O3. Yes, that is nothing but rust. We call it as rust. So remember, see, there are sometimes students get confused between what is rusting and corrosion. They use vice versa. See, rusting is a special type of corrosion only applicable to iron. Okay, don't mix it with any of other metals. Clear? So we have done till fourth question. Let's move to the fifth question. So students, let's move to the question number 5 here. So it is again a process which we have already studied, that is the electrolytic refining, but in detail. Okay, so here asking about what we have to use as a cathode, anode, and then the electrolyte and all those things. Okay, so it is basically defining, it's a 4-marker question which has been asked as a case study based question. So what is the cathode and anode made of in the refining of copper? So we are trying to get the copper here. So what do you think we are going to use cathode and anode? See, in electrolytic refining, we are going to use cathode and anode, both the same metals which we have to refine. And even the electrolyte, what do we take the electrolyte as? The electrolyte will be nothing but any metal salt, the metal which we are trying to refine, that metal salt we have to take it, right? So which one should we take it in cathode and which has to be in anode? So remember this always. I used to tell to my students also that anode mud, when we are studying about this process and all, we have come across a word called as anode mud, right? So that means where do you get mud? Where there is dirt. So that means anode has dirt. That means I'm going to take my impure copper metal, impure copper. So basically anode mud, you can remove that. Anode is nothing but my copper impure. Okay, impure copper you will be taking in the anode. And what about the cathode? Obviously cathode should be your, what do you get? The pure copper metal. Okay, that will be a thin strip we will be trying to take it over there. And yeah, so what is the cathode and anode made of in the refining of copper? So cathode will be the pure copper metal strip and the anode will be the impure copper metal strip. Now what is the name of the solution used in the above process? Like I said, you have to take that particular metal's salt solution you have to take. So I will be taking, you can take any salt, you can take copper chloride or you can take copper sulfate. Let's go ahead with copper chloride. Okay, I'm going to take copper chloride or copper sulfate. Any of the salt solutions you can take it. Okay, now coming to the next one, how copper gets refined when electric current. So we are doing basically the electrolytic refining, right? So how do you think this is done? So when the current is passed, what happens is from the anode the copper ions Cu+2, the copper ions, where do they go? The copper ions, they deposit or go into the electrolytic solution. Okay, what happens to the electrolytic copper ions? What happens to the copper ions which are generated when electricity is passed to the electrolyte? So obviously the electrolyte copper ions, they go into and get deposited over the pure copper element, okay, or the metal strip near the cathode. Are we clear with how the electrolytic refining is done? So basically we take the impure copper metal in the anode, and the pure copper metal we will be taking in the cathode, and the electrolyte will be the salt solution of the metal which we want to refine. So here I am going to take it as copper chloride or copper sulfate. And how do you get it? When electricity is passed, the copper ions from the anode get deposited into the electrolyte, and simultaneously from the electrolyte the copper ions get deposited over the cathode, making the refining of the copper metal will happen. So this covers this entire thing. And coming to, there is one more question here. As you can see, this is a completely different OR question, which is, so you have two beakers A and B containing copper sulfate solution. What would you observe after about 2 hours if you dip a strip of zinc? So what is the key word here? Copper sulfate. That is critical. Okay, and you are dipping a strip of zinc in beaker A and a strip of silver. So what concept is involved in this question? Yes, obviously it is the reactivity series. So you have to identify which is above the copper and which is below the copper. So zinc, where do you think it is? Is it more reactive than copper? Yes, obviously. So that means, do you think reaction will happen in beaker A? Yes. So after 2 hours, you can start seeing that the bluish color of the copper sulfate will start to fade out. So reaction will happen in beaker A. You can write it as some reaction. The chemical reaction will happen, and slowly the bluish color of the copper sulfate will start to fade out. You can write that. What happens in beaker B? Where in the order of the reactivity series is silver? Is it above or below? So Ag, which is nothing but the silver, gold, platinum and all are in the bottom end of the reactivity series. So they don't react with the copper which is above them. So there is no reaction in beaker B. So it will be as plain as blue as what it is at the starting also. So I hope this question is clear for you all. So shall we all move to the next question, which is question number 6 on the screen now. So question number 6 is a 5-marker question from 2023. Again, it is based on the reactivity series. You have to remember those reactivity series without fail, which I will cover in the last part of the session. So carbon cannot reduce the oxides of sodium, magnesium and aluminum to their respective metals. Why? This is a statement problem. And where are these metals placed in the, see, you can see there is one question, second question, and how are these metals obtained from their ores, which is nothing but the extraction of metals. Again, the extraction of metals comes into the scene here. So these are all very important topics which you cannot ignore during your preparations. And you have to take an example to explain the process of extraction along with chemical equation. The best, obviously, which is given in our textbook is also about the extraction of sodium. So we will deal with that. So why do you think carbon cannot reduce the oxides of sodium? The simple reason, carbon, where is it? Is it in the reactivity series? It is at the below of these metals. So you can't go with the reduction of carbon with these metals, which we have even discussed in the previous problems. So the statement should be according to the reactivity series, both sodium, magnesium as well as aluminum, where are they placed? More reactive than carbon, and these elements are above the carbon in the reactivity series. So because of this less reactive nature of carbon, it cannot displace from their oxides. That should be your statement. And coming to the next one, where are the metals placed? Metals of high reactivity like these are placed, are extracted. Where are they extracted? Through the process of electrolytic reduction, which we have gone through numerous problems. So what exactly happens in the electrolytic method? You have to draw the figure of the electrolytic processes where the anode mud and all has to be shown. So what is the reaction exactly happen at the anode? Anode is positive charge. So chlorine gas will be liberated over there. So two chlorine ions will be releasing the 2 electrons, and it will start to liberate the chlorine gas at the anode. Similarly, what happens in the cathode? The sodium ion, it gains one of the electron and then starts to form as a sodium metal. So what is the overall reaction? So NaCl, you know, right? The electrolyte only will start to deposit over the cathode metal element. So NaCl will be deposited into 2Na and Cl2. So this covers your entire question of electrolytic refining and whole thing. Okay. So coming to the next question, which is question number 7. These are a few 3 markers. I have even added one assertion and reason also, which can be expected. So among the following metals, which is having the lowest density? Lowest density means lowest mass, lowest atomic mass. That means it should be at the starting of the series, the periodic table basically. So if you see lithium, lead, magnesium and aluminum, you can see all these are metals, but which is the first metal in our periodic table? It is nothing but our lithium. So which is the metal having the lowest density? It is nothing but lithium. So the answer is lithium. Coming to the next one, this is important. Please mark it as a very, very important. The number of electrons in the outermost shell of an atom of what? They are asking for a non-metal, not for a metal. So this is a key word here. So you have to underline the word non-metal. So for a non-metal, what type of ions do they form? We know metals like sodium, aluminium and all. What and all, which type of ions do you think it has formed? They all formed positive ions, right? So that means they will lose the electrons from their shell, outermost shell. So what about the non-metals? Non-metals and metals, they form ionic compounds. So one has to be an anion. So that anion is nothing but the non-metallic ions. So which and all can form? So let's observe. If I'm having 1, 2 or 3 electrons in their outermost shell, you can see sodium has 1 electron, magnesium has 2 electrons, aluminum has 3 electrons. So they are losing the electrons. So are they metals or non-metals? They are metals. So this is a removable case. So it's an you can obsolete it. Now coming to the next one, even 3, 4, 5. Already 3 is existing in this one. So how can they can include in option B? So this also can be removed. Now come to the C part. Yes, I can see 5, 6, 7, which can be an example of nitrogen, oxygen and fluorine. So they all have a valency of 3 minus, 2 minus and minus. So that means basically they are having 5 electrons in their outermost shell. This has 6 electrons and this has 7 electrons. Now, okay, this looks like a correct option, but let's look at the D option also. 5, 6 or 8. There is a mistake over here. If an element is having 8 electrons, that means it is already stable. So can I go with option D? So this is also a wrong answer. So what is the correct option? Option C. So go according to the options. Please be careful. Write the known examples from the electronic configurations which we have already learned. So come to the last question. So assertion. It is given sodium oxide is an amphoteric oxide. What is an amphoteric oxide? We have already discussed it in our one of the previous question. Amphoteric oxides are those oxides which are formed from metals which can react both with acids as well as base. So what are those 2 metals? There are only 2 metals which we have studied, which are the zinc and aluminium, but they have given sodium oxide, which is not the case. Okay, so assertion is wrong. And what about the reason? Metal oxides which react with are called as amphoteric. This is the basic definition of amphoteric oxide. So what is the correct answer? A is wrong, but R is true. Okay, so this is your question number 7. Let's move to question number 8 now. Yeah, so with the help of a suitable chemical equations, it's a 3-marker question. With the help of suitable chemical equations, list the 2 main differences between calcination and roasting. So which concept am I covering here? Again, I am covering the concept of extraction of metals. But what is the speciality of this roasting and calcination? So pause the video for a few minutes and try to answer this. Yeah, so on the count of 3, 2, 1. Yeah, so what is the answer? So calcination is basically nothing but it is carried out, the differences basically. You can list this even as a table also. Calcination is carried out by heating the ore in the presence of oxygen or in the presence of air or in the absence of air. It is carried out in the absence or a limited presence of air. So calcination, this is the key word here, limited or absence of air. But when it comes to roasting, roasting is happens when there is an excess presence of air. So this is the 2 critical differences between the calcination and the roasting. What is the second main difference? Calcination is used to convert which compound to which compound? Okay, calcination. So how do you remember, sir? How can I remember calcination is for which compound conversion? So C, calcination starts with C, right? So you can remember that it is used to convert the metal carbonates. So metal carbonates to the metal oxide. So that is what calcination does. C for C. C for calcination converts carbonates ores to oxides. But what does roasting do? What is R? S, Q, R, S, T. So in the order R, S, R is followed by S. So like that, try to come up with some easy techniques or tricks to remember how can I remember few of the things. So calcination converts carbonate, while roasting converts sulfide ores into their oxides. So I have given an example of zinc carbonate and zinc sulfide, how it is being converted. Very important. Many students has asked also, so should we write a balanced chemical equation or not while we are giving examples? My sincere suggestion will be always write. Did I mention a balanced chemical equation or not here? Yes, I have given a balanced chemical equations. So always prefer to write the balanced chemical equations. Okay, for the roasting example, I have given that. They have even asked, how do you convert these metal oxides to their respective metals? So that has been covered here. The metal oxides are then reduced to the corresponding metals by using suitable reducing agents. What is the best reducing agent which we have discussed already? It is nothing but, always remember, it is carbon followed by hydrogens. Okay. So for this example, I have taken zinc oxide because I am using the same example here. So zinc oxide, when I am reacting with carbon, what does it form? It reacts the zinc metal and it liberates carbon monoxide gas. Okay, so this entirely covers the 3 markers which is required for this particular question. So let's again move to the 9th question now. This is a 3 marker again asked in the 2023 board examination. So these type of questions you can expect, because they will just suffice the what is this M and all those things and all. So they will keep it as a hidden treasure like that. So a metal M on reacting with the dilute acid, okay, this is important. A metal M on reacting with the dilute acid liberates a gas G. Fine. Okay. You should remember metal, what happens when it reacts with any hydrochloric acid or something like that. What is the gas it liberates? That you keep in your mind. Okay. The same metal also liberates gas G when it reacts with the base. Oh God. So it is given that there is an acid and a base. So it is reacting. So what is that? What is that metal which reacts even both with the dilute acid and the base? It is nothing but an amphoteric oxides and all will be forming. Okay, so let's start the answer with this one. So what is the metal? What is the name of the gas liberated? Like I told, it is nothing but, what is the gas liberated when metal reacts with HCl? It is nothing but H2. So my answer for the first question will be H2. Hydrogen gas. Hydrogen gas is liberated. Now, how do you think you will test the presence of this gas? How do you, this experiment has been conducted in the labs also. So how do you think you can check the presence of hydrogen? Yes, you bring a lighted candle or a matchstick on top of the lid of the test tube, and when it is exposed to the liberated gas, what happens to the lighted fire? It starts to give a pop sound. Okay, so that is how you will test the gas. Now write the chemical equations for the reactions of the metal with acid and a base. So this task I am giving it for you to solve it. Okay, so we have covered question number 9, CBSE 3-mark question. This is very, very important, where you can expect these type of questions. Okay, shall we all move to the next question, the final question of our session, question number 10. So this was a question which is given as a 4-marker, again a case study based question. The melting points and boiling points are given for some metals, metallic salts here. These compounds are termed as ionic compounds. So let me directly go to the the questions here. Show the electron transfer in the formation of magnesium chloride. We have already studied about Na2O. I have told you how to do it. So can you do it? I am going to pause the video. Please pause the video here and try to draw the electron transfer from magnesium chloride. The same way how we have done for Na2O. I'm giving you a few minutes of time. So quickly solve how can you form magnesium chloride using the proper electron transfer or electron dot structure. So the answer for this one, are you done? So shall I go? So it is given as, so just like magnesium, what is the valency here? You can write the electronic configuration. It is 2, 8, 2. What about chlorine? I think we already have done it once. 2, 8, and 7. This is for chlorine. So what is the valencies of magnesium and chlorine here? Mg is +2. You can see it can lose 2 electrons, while chlorine, in order to attain the stability, it can gain 1 electron, right? So this has 1 minus. So crisscross method again we will use, and what we will get? MgCl 2. So this is the compound electronic formula, I mean like chemical formula. Now what is the electron transfer? How is it done? Again, Mg, you will write the how many electrons will be there? There are 2 electrons. So either you can keep it here or you can change also, that is up to you guys. But you have to show those 2 electrons which are available for transfer. So I'm going to keep it as Mg here, 1 here and 1 here. How many chlorine atoms are we supposed to have? There are 2 chlorine ions, so 1 chlorine and second chlorine, and it is in short of. So I should use a different notation for the second element's electrons, because I already have used cross and cross for magnesium. I can go with the dot for the chlorine. So I'm going to use that chlorine dot, it's pending 1 2 3 4 5 6 7. Okay, and the second chlorine also, it is also pending with 1 electron to be needed. So this transfer will happen over here and the second will happen over here. So this completes the electron dot structure. So how do you write the complete thing? Mg plus 2. Okay, so it has already lost its 2 electrons. So what about the chlorine atom? It will have 2 chlorine atoms. So 1 chlorine atom you will write, either you can write like this, dot, dot, cross, cross, dot, 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 and you can write 2. And this is minus. Okay, so this is how the electron dot structure is done for the magnesium chloride. I hope that you have understood. The next question is very, very important. The next one is list 2 properties of ionic compounds besides the high melting and boiling points. So they are just asking you to list out, not to write or elaborate the properties. So what are the 2 properties? One is you can take the physical nature. What are the ionic compounds? Basically, what is the physical nature of this ionic compounds? They are solid in nature. So that you can write down. What is the second one? Conduction of electricity. So ionic compounds, they can conduct electricity only in the solid state or in the molten state. They can conduct electricity only in the molten state but not in the solid state. Why? See, you no need to write that in this point because it is only for 1 mark and they have just asked to list out, not to elaborate. So just list out these 2 properties and that will be more than enough. And coming to the third question, while forming an ionic compound, say sodium chloride, NaCl, how does sodium atom attain its stable configuration? So you have to explain about how the transfer of electrons will happen and how it attains the electronic configuration. So you can show again the nature of Na. You can show again Na plus Cl minus the electron dot structure you can show, and you can elaborate or you can explain properly with the listing outs. Now coming to the last question in this, which is give reasons. Why do ionic compounds in the solid state not conduct electricity? I was just explaining that while listing out the properties. Why do you think in the solid state they don't conduct electricity? Because they don't have any free electrons to vibrate or to move. So because of that reason, they won't be able to conduct the electricity. They are very tightly packed and they can't move further. Okay, so that is one of the reasons for ionic compounds not to conduct electricity in solid state. But in molten state, they have free electrons to move. Okay, it is already ready to give away the electrons. So that is the reason. Okay, and coming to what happens at the cathode when electricity is passed through an aqueous solution of sodium chloride. So at anode, what is happening? We have seen at cathode, we are going to get the metal. And at anode, what happens? Sorry, this is what is given. At cathode, what is happening? We are going to get the metal, which is nothing but the sodium metal. So you have to just write down clearly the statement. I think if I just go back to the previous questions where I have shown for Na. So yeah, the 7th question, I guess. 6th question. Yeah, so at the cathode, what is happening? Sodium ions gains 1 electron and they will form Na sodium metal ions. Okay, so this is our 10 questions for this session. And like I said, I'll be displaying now the most important topic of this entire chapter, which is nothing but the reactivity series. So shall we go and look at what is the important topic, just like I said before the start of the sessions? Yeah, so it will be the reactivity series. So how to remember? Students find it a little bit difficult to remember the order of the reactivity series. So we have given a small trick to remember, that is like, please stop calling me a cute zebra, I like him calling smart goat. So what does this mean? The first letters of this whole statement or the sentence will give you the first the order of the series. So P for potassium, that is K, S for sodium, C for calcium, M for magnesium, A for aluminium, C for carbon, Z for zinc, I for iron, basically Fe, and L for plumbum, that is lead, okay, and H for hydrogen, C for copper, S for silver, and G for gold. So this is the order you can remember. And coming to the top, which and all comes under the more reactivity series, especially up to aluminium will be covering under the highly reactive metals. And coming to the next one, the carbon to hydrogen will be considered as moderate in reactivity. And coming to the last three, which is carbon and henceforth, will be considered as least reactive metals. And coming to the extraction of ores, extract metals from the ores. So we have listed out how the flow chart is. So if it is a medium reactivity, highly reactive, and a low reactive, so how it is extracted has been also listed out. Especially the medium reactive, we have both calcination as well as roasting processes. Now coming to the last one, which is the electrolytic refining, which I have explained. So this is the copper sulfate solution, and it is the refining of copper, which we have already studied about. So anode will be taken as the impure copper, and anode mud will be deposited once we pass on the electricity through the circuit. And the copper ions from the electrolyte will be deposited onto the cathode, which to form the pure copper metal. And this size of the anode will start to shrink, and the size of this cathode will start to become big and bigger. Okay, so this is what the entire concept of metals and non-metals covers up. So this chapter covers nearly 6 marks in your board examination. So you have to be very careful. This is one of the high weightage chapters which you have to concentrate, and please study well, and I hope you will all score more than 90+ in the upcoming board examinations. All the best, students. Thank you.